Hello YouTube. So how it's going? And recently on LinkedIn as well as on Telegram, I was asked about how do you get started with quantum computing? I mean, what should be the resources that you should use to get started? So I thought, why not answer it to everyone all at the same time? So on number 5, I will keep this book, Quantum Computing and Applied Approach, and I will justify my decision. So this is a great beginner-friendly book. It does not focus too much on mathematics, but it successfully gives you a great overview of the field. And I have personally read this book, so I know it's a great book. So if I talk about the key features of this book, then it starts with history of quantum computing. It just talks about how this concept of computation based on quantum mechanics just came into existence, then how it got a boost by the statement that was made by Richard Feynman, and it also talks about the basic principles from quantum mechanics about quantum superposition, entanglement, and it slowly starts giving you that feel of quantum computing. Then slowly it moves to the basics of quantum computing. So it talks about the direct notations, the single qubit gates, two qubit gates, the matrices that represent them, the measurement theory, and it starts giving you the math and how these calculations are made whenever you work with quantum computing. Then once done with that, the basic of quantum computing, it starts talking about the hardware aspect. So there are various means of realizing this qubits using the actual physics concepts like NMR techniques, trapped ion techniques, photonics, superconducting qubits. So it talks about all of these techniques in brief. So any beginner would actually know about these techniques. So it's just not about the mathematics. It also gives you the actual sense of how this is realized when you do actually quantum computing. Then after that, it comes to the software toolkits that are available. So how can you actually practice quantum computing? So it introduces you to all the important software toolkits like Qiskit by IBM, Circ or Circu by Google, PennyLane, and it introduces you to almost all the major software toolkits. So I think that's a great section in this book. Then it starts talking about the quantum algorithms. So the dot Giosa algorithm, QAOA, variational quantum eigensolvers. It talks about all the basic algorithms that any beginner needs to know. And then it also covers the mathematics for quantum computing. So it's the linear algebra, eigenvectors, eigenvalues, all those, all that part. And if you're someone from machine learning, I think you would already know all these things. So with that said, let's move on to number 4. So on number 4 comes this book, Quantum Computation and Quantum Information. And again, I have read this book. It's a great book, but compared to the previous book, this one is a little more intensive. So again, it starts with the basic concepts, the fundamentals. So what is a qubit and what is quantum computation in general? It just talks about all that. But in addition to that, it also talks about quantum mechanics as well as computer science. So irrespective of your field, you can approach this book. Then slowly it turns to the quantum algorithms. So the basic algorithms, Dodge algorithm, Dodge Josa algorithm, and slowly and steadily it then moves to quantum computation. So more complex algorithms. It also talks about the quantum circuits. It talks about the physical realization of these qubits and all those things. Then finally, it comes to the most interesting part, I guess, which is quantum information. So as you can see, the title itself involves quantum information. So it talks about the quantum information theory, quantum error correction, and all those amazing concepts. So I think it's a great read, but again, I think it's a little more intensive than the previous one, and it will take more time to read than the previous one. So that's why I have kept it on number 4. But definitely, it's a must read if you want to get into this field. I think it will really help you to expand your knowledge. So let's move on to the third one. So on number 3, I will keep my YouTube channel. So I'll again give you reason for this decision, and you can see there are a lot of videos. As of now, there are only 79 subscribers, but it's fine. I have just started this almost a month ago, and I think the two most important videos on the channel right now are this quantum machine learning project with TensorFlow Quantum and Circ, which is almost about 2 hours, as you can see here. And the other important video is this 4-hour video, which is again about the quantum computing project. And this quantum computing project is intended for someone who wants to get started in the field. I have literally tried to cover everything that's possible that you need to work with this project. And for anyone who has a decent amount of knowledge in machine learning, I think should be able to work with this quantum machine learning project. So as of now, I don't have much of material on the channel, but I'm just trying to make a roadmap for quantum computing. So anyone who wants to get into the field can directly look to YouTube and get going, right? And the reason to keep this YouTube channel ahead of the other two books is that this is the active way of learning. So what happens is that when you just keep on reading books or just keep on attending summer schools, you may understand the concepts, but you may feel a little lost, right? You may lose the motivation, and you may not even complete reading the book. So when you are actively yourself working on a project, you definitely understand better. And these projects that I have chosen are very beginner friendly, and the quantum computing project, this 4-hour video that you can see, is actually helps you to develop a visualization tool that again helps you ahead in your journey so of learning quantum computing. So I think that's something great, maybe. uh, and again, as we go further, I will try to focus more and more on quantum computing, machine learning, and quantum machine learning. So yeah, the enough of talking. Let's move on to the second resource, which again comes from YouTube. So on number 2, as I said in the previous section, another resource from YouTube, and this is a great 41 videos uh, focused on quantum machine learning, but it also introduces you to quantum computing, and then it slowly moves on to quantum machine learning. You can see there are a lot of videos, 41 videos, as I told you, and it's a great resource that is freely available. You can see variational circuits and quantum sampling a thermal state, QAOA, quantum annealing, adiabatic quantum computing. So it briefly talks about almost everything, and it gives you a great background of quantum computing as well as quantum machine learning. And again, it's freely available on YouTube. So I definitely think you should check this one out. And it's a top-notch uh, content that's available. So that's the reason I kept it on number 2. And with that said, let's move on to the number one resource. And again, that resource is freely available, and I think it's the best resource available right now for quantum computing. So let's go and discover the number one resource. So as the number one resource to learn quantum computing, I present to you the IBM Acoustic Textbook. Uh, this is a great resource to get started with quantum computing and learn these concepts. It's definitely freely available online, and as you can look at the index here, it's quantum states and qubits. Slowly starts with the basics, then it jumps into the multiple qubits, the concepts of entanglement, Bell states, then the quantum algorithms, the basic ones initially, and then it moves on to more complex stuff. Then again, it gives you the information about the HHL, QAOA, variational quantum eigensolver, hybrid quantum classical neural networks with PyTorch, and then it also talks about the hardware. It, and then it also has quantum computing labs for you to practice, and a little section at the end of games and demos, a little project that you can look out for a little active learning. So I think it's the best resource that you can look out for, and just check it out. I really think it will help you to get a sense of it, at least a sense of what quantum computing is, and if that field is for you or not. And with that being said, I really hope that as I make content on my YouTube channel, I am able to reach this quality of content that provides everything to the user, and let's see if it happens or not. But anyways, I really wish you all the very best for your journey ahead in quantum computing, and that's it from my side. See you in the next one.